Hi everyone. I have a few days left remaining on my free version of Camtasia video software. So I thought I'd record another video for you, some tips and tricks around Primavera P6 for shutdowns, turnaround outages, and pit stop campaigns. As you know, Primavera P6 was not designed for doing these intense, dynamic, risky projects, shutdown, turnaround, outage events, or pit stop campaigns. However, there is an opportunity for us. It is a very powerful tool. It has great scheduling engines and algorithms in the background, things that we can use to dynamically schedule and control or drive and navigate our events. So what I'm going to show you here is really about the process availability, or the time that we have available by system or unit equipment to repair, inspect, overhaul, and return back to service, to operations. So a few things. Primavera P6 does not phase projects, okay? It has a hierarchy, a vertical hierarchy of what they call WBS, and we don't use WBS in stop events. We use what we call the asset systemization structure, and I'm going to just show you here quickly on this particular project. When you look at what is typically referred to as a WBS, I'm going to relabel this called ASS, is my asset systemization structure. Yeah, I know it's a little bit funny, but bear with me and I'll show you how it works. What I'm saying is that this structure must represent or mirror your flock system in your SAP, ERP, or CMMS system, or whichever CMMS system you're using. The functional locations and the hierarchy or structure of physical assets in the manufacturing facility must line up and integrate. So there are three things that must line up and integrate. This structure, the asset systemization structure, the work order number, the equipment ID, and in some cases, the cost center. So what I'm doing here is I'm saying that I'm going to break things down into certain units and plants and systems in my asset systemization structure. And I'm going to go down to one here that I've called the MDEA unit. And you can see here that I've created two fields, custom fields in my structure that says handover to maintenance, which is lottoed or isolated, and a time to hand back to operations, PSSR, mechanically certified fit for service for startup. This window is called the process availability window. And again, P6 Primavera, unfortunately, does not let you hard code these windows, but I can choose these dates that I'm sitting with operations and they're telling me that I'm going to hand over this system to you on February 12th, 2024, and I'm going to hand it back, or I want it back again on the 29th. So how are we going to manage that? When you go over to the activities, you'll see here that I'm using ordinal dates here. I'm just going to show you for a moment how I'm doing this. So I'm choosing 3 lines on my timeline, and I'm using ordinal dates because everything to me in a stop event is based on days, like day 1, day 2, day 3. So I'm going to be using those numbers rather than the actual dates as I discuss this with you. So what I've done here is I've said that I'm going to create this window of opportunity. You can see here that this curtain is set up such that on day 4, the MDEA unit is being handed over to maintenance mechanical, and on day 21, it has to get handed back to operations. So this is my window or process availability window of opportunity. It could be based on systemization, unit, plant, a number of things that operations wants to hand over, for example, the flare system or the steam system. And they say, here is the system, lottoed. We'd like it back for PSSR and mechanical completion certificate on this day. So how do I do that? So again, I'm going to go in and create this window. I'm going to use calendars. So I've got under my project, okay, under project, I have created the windows of opportunity based on that structure, what operations has given me. You'll see also under global, I have a template that I utilize for creating my process availability window calendars. Now, these templates are created in global. This one is for 2024 event, and you'll see that in the year of 2024, not a single day is available to work. everything is non-working time for this entire year, okay, all the way through until January. The next available time that we can work is on January 1st, 2025. Why did I do that? Because when I go to create a project process availability window, I'm going to use that template as my starting point. So what I've done is I've gone in and said, okay, I'm going to modify this now. I'm going to go to the particular date here, February 24th, because my project is starting. Day one is on the Friday, on the 2nd. And so what I'm doing is, on the 9th. And what I'm doing is I'm creating a window here. So I'm saying everything up until the 12th is non-working time, but everything from the 12th to the 29th is a 24-hour open, available to do work in this window. As I get to March, nothing is available. So the only window of opportunity is here. So I create that and I assign that calendar to these activities. And by doing that, it will automatically put these activities into my window. You'll see that it won't allow any activities to go left of that window of day 4, and it will not allow any to go right of day 21, the 29th. Okay, it's stopping here and it's measuring my float up until that point. So what does that mean for me? That means that when I take this window with these activities or these tasks, so here I have a task of open, clean, inspect. I have all these activities. I've prioritized them, and I've created my activity priorities, my task priorities, my grid, my permit, my risk, and my different classes. I've got my resources assigned. All I need to do now is run the dynamic scheduler based on the key P1 resources that I'm using: pipe fitters, boiler makers. These, you can see my P1s down here. And I'm leveling within the available float. So this is my available float here. If I did not have this turned on, anything that is over allocated would go outside of this window. So I want to keep this on. I want to preserve 24 hours of float, and it's acceptable to run 10% over allocation. I'm going to run it I'm going to dynamically schedule by task priority, then by activity priority. That means that, and then by grid and by risk. And what I mean by that is it allows me to do this one. The computer will schedule this task or this work package first, this exchanger, and it'll do this by doing the activities in order from in an A to Z format. So here I'm just going to go ahead and level. I'm going to move this out, and you'll see that what it's done now is it's dynamically created this plan for the entire project, utilizing the resources available and keeping everything within that time frame to demonstrate that it's quite possible with this number of resources. So here I have my available crews. I have my productivity factor, in this case a 1.5 productivity factor. I could go in and change that productivity factor at any time for the phase or for the resource. I could go in and say that the productivity factor for this at this point now is going to be 1.8. So I would move it to 1.8. I'd go back and I would do my dynamic scheduling again, and it would paint a different picture for me in terms of how my project is going to look. So again, process availability windows. I set up my curtain. My curtain says from the 12th to the 1st, which again is my day 4 to my day 21. I'm creating that curtain, and I've assigned that calendar to these particular activities. Now here you'll see that these activities have been assigned to the mechanical phase. The mechanical phase runs all the way through until startup. You see here is my startup phase. Mechanical phase runs right through until startup. If I was to change this calendar to a MDEA unit and again do my dynamic scheduling, you'll see that it will pull everything back into this window. Okay, so it won't allow anything to go outside there. This way, I don't need relationships. I don't need milestones. What I'm trying to do is limit the number of relationships. And remember, again, this is logic and activities. This is part of the planning. This is logic, not a relationship. This is logic and activities. If I connect this task, overhauling a PSV work package, to this activity in this work package, this is a relationship. This is one of my techniques for scheduling. So remember, my techniques for scheduling are the constraints, relationships, dynamic scheduling, prioritization, programming, scheduling. I put a bit of a paper out yesterday on some of these different terminologies and techniques. I'm trying to minimize the number of relationships. Why am I doing that? Because these projects are so dynamic that we know that sometimes things are going to change. And what we want to be able to do is go in and reprioritize it. For example, maybe this exchanger is now going to be the highest priority for whatever reason. That way, when I go back into do my dynamic scheduling, it's going to pull this exchanger in and it's going to push out some other work. And so I'm going to go through and perhaps I'm going to change this to a priority 4 because operations or the execution team said that this exchanger is just not available. We need to put it on the back burner for now and pull some other work in. So I'm going to quickly make that change. I'm going to move this one out, pull this one in, and again, pull other work in and out of the program. So that's, again, let me go back and show you when we do, as a summary, when we do our asset systemization structure. Again, it's not work breakdown structure. It's the footprint of the plant physically based on flock, based on the structure of plant, unit, system, subsystem, all the way down to a piece of equipment. You'll see here I've got all of my equipment is signed. I brought everything over to my project from a equipment standpoint where I have my work orders. Okay, so I brought all my work orders in as activity codes. And then globally, I brought in all of my equipment IDs. So here's all of my exchangers, my pressure valves, and this is how I've created my equipment ID and my work orders and tied them to the equipment. But here in the process, I've said that the main gas compressor, for example, is available from the 12th to the 3rd. That operations handed it over to me. Lotto, they want it back again on this day on March 3rd for PSSR and mechanical certificate and startup. So when I created main gas compressor window of opportunity or the process availability, I went in similar to what I did here with the cooling tower. You'll see here down here I have a cooling tower window. I've gone in and said, well, this cooling tower is available. The process is going to give it to me on the 16th and they want it back on the 22nd. So when I go in and look at it from the utility standpoint, and again, this is all based on what operations says they need to give me this cooling tower, for example. So here's my equipment, cooling tower. Here is the work that's done by in the mechanical phase on the cooling tower. I can quickly put in my process availability cooling tower phase and within this mechanical phase. And this is where the cooling tower is going to be scheduled from day 7 until day 14. So again, that's something that you can consider using. I find it incredibly helpful, and it's part of my dynamic scheduling and programming. So it's not scheduling, it's programming. And then from programming, I'm going right into dynamic scheduling. So when you look at people who talk about using F9 to schedule, F9 does not schedule. F9 simply refreshes any changes that I, as the scheduler, might have made. So remember, there's 2 schedulers in the room. One is human, one is machine. I would much rather use the machine to do the majority of my scheduling to produce the most optimized plan. And what is that optimized plan? It's the least amount of money, the shortest duration, and the least amount of resources to get this work done. So you'll see here, I have a $1 million budget, I have 22,000 man hours, and I have 224 hours of chronological time. Okay, chronological time versus the time that we talked about in the last video. I believe I showed you that the time associated with an activity duration with this resource, duration times units per time equals my man hours. This is my true duration here, 2-hour duration. When I look at the actual duration on this particular PSV, this could be dependent on the productivity factor and depending on all the other work that's going on, could end up taking me 8 hours in actual chronological time. It could take the entire shift to earn that 2 hours, depending on availability. But that's for another video. So for now, remember, process availability, phasing your project, open, clean, inspect, repair, closure. Phasing is horizontal. It has a timeline. P6 does not phase, so you have to force it into phasing through calendars. The WBS should not be used. It should be turned into what we call the asset systemization structure, which is a vertical representation of the hierarchy of the physical asset. Okay, so any questions, send me an email, drop me a line, drop me a message. Otherwise, stay safe. Have a great day. Cheers.